what we are going to build on today, and we're not going to do anything new in this section on linear functions, is we're going to build on the concept of what is the difference, or what comparisons or conclusions can I reach when I compare one linear function to another. Okay. Now, if you recall, nothing new here. The slope of the function is the rate of change, and the y-intercept of the function is the fixed or initial amount. And we now need to relate these to specific scenarios. Okay? Now, I'm going to need to draw this on the graph here. It doesn't show up on mine, but it does show up on your note sheet. My x-axis is my time in seconds, and my y-axis is my distance. And we're talking about comparing a zebra to a lion. Okay? And my distance is by hundredths. And I have 3 points I plotted. 0, 0, 1, 59, 2, 118, and 4, 236. Right? Now, for the lion, you are given that the lion is going at 53 feet per second. You don't need to do any calculations. Now we want to see what the zebra is doing. Well, your y-intercept is 0, 0. And what the y-intercept represents is the fact that at 0 seconds, the zebra's gone nowhere, which just makes logical sense. After 1 second, he's gone 59 feet. After 2, 118. So you should see that his rate of speed, if I were to do 118 minus 59 over 2 minus 1, is he's going 59 feet per second. Okay? That's how we use the graph to figure out the different rate of speed. Now let's go to the next example. I have 2 cell phone plans. Angela, where I give you an equation, and Ben, where I give you the graph. So let's go to Ben's. I'm going to put minutes here. I'm going to count by 40s. So 40, 80, 120, 160. And this is all on your paper. 240, 280. Sorry, it's a little messy. I'll stop there. And then I'm going to count by 10s. So 10, 20, 30, 40, 50, 60, 70, 80, and 90. So Ben, I'm going to plot 4 points at 120, above here, and at 200, he is right at 80. Got that right. It's off by 120, 160, 200 right here. Sorry, like that. Should be able to be connected in a straight line. All right. Now, we have Angela, where we have this equation, y equals 0.15x plus 49. And then we have Ben, who we have represented in a graph. Now, before doing the work here, let's talk about what's happening. What makes up their monthly bill? Their total bill is made up of minutes charge plus a flat monthly fee. The total cost is what y is. The minutes charged is based upon your slope, and the flat monthly fee is based upon your y-intercept. Now, if we look at Ben, his y-intercept is 60. So that means If he doesn't talk any minutes, they're going to charge him $60. So now the question is, how do I know how much they charge him per minute? Well, I could take any 2 points, and what these coordinates represent is for 120 minutes, he gets charged $72. At 0 minutes, he gets charged 60. So how do I figure out his minutes cost? 72 minus 60 over 120 minus 0. So he gets charged $12 for 120 minutes, which works out to be 10 cents a minute. Okay? Because you want to turn it into a decimal since it's relating to money. Now, and if I use the other point of 280, it's the same thing. Because that would be 12 over 8 over 80, which is still 10 cents. Okay? 80 minus 72 is the 8. 200 minus 120 is 80. So no matter what 2 points you choose, you'll still get the 10 cents. Now the question is, who charges more per minute or pays more per minute? Well, it should be simple. That's Angela, because she pays 15 cents versus Ben's 10. What does the y-intercept represent? The flat fee per month. Who pays more if it's 200 minutes used? Well, Angela will pay. Let me just move this. So Angela's going to pay 15 cents times 200 plus 49, which is $79. Ben's going to pay 10 cents times 200 plus the 60 or 80. Okay? All right, let's go to the last example. Ron's dad needs to rent a truck to move some furniture. He can go to Ralph or he can go to Mike. Now, let's do Ralph since we have the table there. If he goes 10 miles, it's $25, 20 miles, 50, etc. So every time he goes up 10 miles, he's tacked on $25. So what does that tell us? That tells us that Ralph charges $25 for 10 miles or $2.50 a mile. Okay? Now, if we go to, and if I were to work that backwards, all right, at 0 miles, he's charging me 0. So Ralph basically just charges me $2.50 X. Now we go to Mike, okay? And Mike, represented by this table, is miles, dollars, going up by 5. Okay, so what this table is telling us is at 0 miles, it's $30. 10 miles, it's 35. 30 miles, it's 45. Just want to make sure I get this. All right, so it looks something like this. Okay, so what Mike does is Mike charges a flat fee of 30, meaning no miles, that's it. But if you take any of these 2 points you'll see that 35 minus 30 over 10 minus 0. For 5 miles, he's charged me $10. Okay? I'm sorry. For 10 miles, he's charged me $5. So he charges me 50 cents a mile, or y equals 0.50x plus 30. Now, who charges more for 40 miles? Well, for Mike and Ralph, let's do Ralph. Ralph, since it's simply $2.50 a mile, 40 times the 250 is $100. While for Mike, it's 50 cents times 40 plus the 30, or $50. Okay? So that's how you would compare the two. Again, the focus throughout all of this is identifying and understanding and relating to actual facts what the slope means, that rate of change, and the y-intercept, that initial amount, and what they are.